Welcome everyone, my name is Bogumił Kamiński and this is the last part of the DataFrames.jl tutorial prepared for the Julia Academy. So before I wrap up the summary of the functionality of the DataFrames.jl package, let me show you just one final example. This time we will be concentrating on joining and reshaping data frames. So we load the packages that we will use in this part of the tutorial. Maybe let me comment on the last two ones because they are new. So unitful package is a package that allows us to attach unit information to the numeric columns in a data frame in particular, and dates is a module in Julia base that allows you to work with dates. So first, let us load the rainfall data frame file that is located in the repository. So if you download the repository, you have this data on your disk, and we load it in as a data frame. So you can see that this data frame now contains three columns: city, date, and rainfall. And so this data is information about forecasted rainfall in different days of 1 week of November of 2020 in two cities, Olecko and Dełk. Why I have chosen those two cities? Because this is the place where I live, so you can check it out if you are interested. Where they are located in the globe. So the first thing we will do is the following. So rainfall actually is collected in millimeters, but when we read in such a data frame from a CSV file, we don't have this information. So we use this unitful package to attach the information about the type, so the units of the measurement of our rainfall in millimeters, and you can see I'm using a transform bank function. So I do in place transformation, attaching millimeter units to my vector, and I use rename calls false option, which means that I retain the original name of this column after transformation. So I just in place change type of data from float to quantity that is measured in millimeters. Next, what we will do, it would be nice to unstack this data frame, so transform it from long to wide format, where cities would be separate columns in our data frame. So this is what I do using unstack function. I'm saying date will be the key column, city is the column that will be used to generate the names of columns after unstacking, and the rainfall are the values that are going to be stored. So what we see here, first of all, that this data has gaps. So for Ełk, for 2 days, we have missing values here and here, which means that we had no observation for this date. And we will soon discuss how this can be handled. The second thing is we have already several times discussed this, but you can see it again, that it's completely not a problem to have non-standard characters like this Ełk character, which is not a standard ASCII character in a column name. I can easily, in this case, just use .Ełk as a column name or .string Ełk to extract this column from a data frame. Now, because we see that we have missings in this Ełk column, it seems like indeed we have a situation that in case there is no rain forecasted for a given day, then in our original file, the row for this day and for a given city was missing. And indeed, we see this is most likely the case, as we are missing here 18th of November 2020. So how to fix this problem? We will use join operation to fix it, but first we create a data frame with just one column date, that is containing dates from 16th to 22nd of November 2020, which covers the whole week. So we can see that here we that was missing above. And now I can left join this all days data frame with rainfall white data frame that we have created here on date column. And moreover, I do one additional thing, because we have noticed that missing value is actually 0 millimeters, so no rainfall. I'm replacing missings in the resulting data frames with 0 millimeters. So you can see here this 0 millimeters, and for example, this row has only zeros, which means that indeed it was missing original. So you can see here that we could easily join two data frames. There is one important thing to remember about joining, that by default in DataFrames.jl, joins do not allow to join on columns that would possess missing values. Actually, we have used this information here because I'm doing coalesce, and I know that I will not replace any value in date column because date column is not allowed to contain any missings. So I'm replacing only Olecko and Ełk columns. I'm replacing missing in only Olecko and then Ełk columns if I'm doing operation, and I'm sure about it because I know that if the date column contained missing, I would get an error. Sometimes it is useful to allow missings to be joined on, and there is an option, match missing keyword argument in joins, which allows for this behavior. So this was the last example I wanted to show in this introductory tutorial that presents a very simple join. And now let me wrap up the whole tutorial. So first of all, it's important to remember that data frame is a matrix-like data structure, so you can index it like a matrix. Exception is that you can select columns using symbols or strings, and if you want to extract a column from a data frame without copying, there is this bank operator instead of a column. So now you have a variety of functions that we have used in this tutorial described for summarizing contents of the data frame, push for adding rows to the data frame. Similarly, there are append, repeat, horizontal and vertical concatenations operations, exactly like for arrays in Julia base. You can group by data frames to attach an index of them, and this has two effects. First of all, lookup of the index is very fast. Second, in transformation functions, they use the information on the index to perform the split apply combine strategy. You have select, transform, and combine functions that allow you to transform both data frames and group data frames. You can filter data frames, you can sort data frames, you can join data frames. All joins from SQL are supported. You can iterate both rows or columns of the data frame using each call and each row function. You can rename columns of the data frame. You can flatten data frames, which unnests them, and such nested data structures are often seen in simulation data. You can easily get number of rows and columns of a data frame with nrow and ncol functions. You can easily allow and disallow missings in the columns of the data frame using respectively allow missing and disallow missing functions. You can remove missings from a data frame. Finally, you can transform data frames from long to wide format using stack and unstack functions. We have also covered several external packages like frec tables for frequency tables, pipe.jl for piping of transformations, glm.jl for generalized linear models. We have shown how to save and read back data in CSV format and in Apache Arrow format. And finally, we show how DataFrames integrates nicely with external packages that even don't know about existence of the DataFrames. Our examples were plotting with PyPlot and attaching unit information with unitful package. Of course, this course was just an introduction, and there is much more. And the three major sources of information are the following. So first, an official manual of DataFrames.jl. The second is tutorial on the DataFrames.jl that I maintain that is much more detailed than this one, and you have it in the second link. And finally, the documentation string of respective functions give you information about all parameters, and most of those documentation strings also give you examples how those functions should be used. So thank you very much for participating in this tutorial, and I hope that it shown you that DataFrames.jl is really currently a major package that allows you to do any type of data wrangling of tabular data that you would normally need in your daily data processing pipelines. Thank you very much.